Selection sort happens to be one of the most frequently asked programming interview questions. In this episode, we would not just understand the way in which the selection sort helps us in sorting the numbers, we would also understand the programming code. And if you really want to have the complete program coded in top 3 languages, then let's get started. Consider these 6 numbers. I want to sort them in the ascending order using selection sort. But what really is the logic of selection sort? Well, the logic is pretty simple. All that we have to do in the selection sort process is to assume the initial element present in the array as the minimum element. In this case, 89 happens to be the initial element in the array, and I have to consider it as the minimum element, but you know for sure that 89 is not the real minimum. There are numbers lesser than 89, and hence I, as a programmer, will have to scan through the entire array in search of the real minimum. And once I find the real minimum, and in this case 17 happens to be the real minimum, all that I have to do after that is to swap the assumed minimum with the real minimum like this, and the remaining numbers would remain as they are, after which I will have to repeat the same process. In the next step, I'll have to assume the next element present in the array has the minimum. In this case, it happens to be 45. But then it is an assumed minimum and not the real minimum. And in order to find the real minimum, I will have to scan the array from the next position onwards. And this helps me to locate the real minimum, which happens to be 29. And once you find the real minimum, all that you have to do is to swap the assumed minimum and the real minimum like this. And the remaining elements would be as they are. After which, again I'll have to repeat the process by assuming the next element as my minimum element, in which case it happens to be 68. After which, again I'll have to scan the remaining portion of the array in search of the real minimum, and you know the real minimum happens to be 45, and then I will have to swap the assumed minimum with the real minimum, and the remaining elements would remain as they are. After which, again I'll have to proceed assuming the next element, that is 90, as the minimum, and then go in search of the real minimum, and you know the real minimum happens to be 68, and I'll have to swap again the assumed minimum and the real minimum, and the remaining elements would be as they are. After which, in the next step, I would again assume the next element, which is 90, to be the minimum, but then when I'll scan the remaining portion of the array, I get to know that 89 happens to be the real minimum, and hence I will have to swap the assumed minimum and the real minimum like this, and the remaining elements anyway would be as they are. And you can notice that the numbers have got sorted in the ascending order. So it is a pretty simple logic. I'm sure you have understood the logic of selection sort, but then if you have to convert all of this to programming code, I will have to explain the logic much deeper. So let me just have my original array on the screen. Also, if I will have to sort all of this in ascending order using selection sort, I would require a few variables. To be more precise, I would require 4 variables: I, j, k and min. And the initial value of I would be 0. Not just that, the variables min and k also serve a certain purpose, which you would understand shortly, but for the time being, I would just keep them there. And I have another variable j as well, about which I would be speaking. But if you recollect, in the previous episode, I had told you the way the selection sort works. We always, in the selection sort, assume the initial element present in the array as the minimum element. In other words, we had assumed that 89 was the minimum element present in the array. Technically speaking, what we had assumed was that our a of I happens to be the minimum element. So, a copy of a of I am going to keep it in the variable called min. And not just that, the minimum element's position, that is 0, I would like to store it in the variable k like this. But then you know that 89 is not the actual minimum. You also have understood in the previous episode that you as a programmer will have to scan the entire array from the next position onwards. That is, from the first position up to the fifth position in search of the real minimum. And that is the purpose why I have j. What I mean to say is that I would initialize my j to 1 and j has to start from the first location and scan the entire array in order to search the real minimum. And how does all that happen? Let me explain. If I will have to find the real minimum, all that I have to do is to compare my a of j with minimum. And if in case my a of j happens to be lesser than minimum, then I will have to update my minimum as well as update k. Well, if all of this is really confusing, let me apply this on the array and I'm sure you would be able to understand. Look at a of j in the array. It is 45, and if you'll ask me, is a of j lesser than the minimum? Then yes, 45 is lesser than 89, which means that this condition is satisfied. And when the condition is satisfied, obviously I'll have to execute the body, and in the body it is suggested that I will have to update both min as well as k. So I am going to update my new minimum as 45 and the position as 1. But then who knows whether really that happens to be the real minimum. I would be able to get to know who the real minimum is if and only if I scan the entire array, which means that next I will have to increment j and repeat the same process. This time the value of j is 2 and a of j happens to be 68. And if you'll ask me, is a of j lesser than the minimum? No. You can notice that 68 is not lesser than 45, so the condition is not satisfied, which means I need not execute the body, but then my scanning of the array is still not completed. So I will again have to increment j and go to the next position, and in the next position my a of j happens to be 90. And obviously 90 also is not lesser than my minimum, and hence the condition again is not satisfied. But I am not supposed to stop because my duty is to scan the entire length of the array, which means that I will have to again increment j and move to the next position, and this time my a of j happens to be 29. And if you'll ask me, is a of j lesser than the minimum? Yes, you know that 29 happens to be lesser than the minimum 45, which means that the condition is satisfied. And whenever the condition is satisfied, the body has to be executed, and the body suggests that I will have to update both min as well as k. So I will update my min to 29 and k to 4, and then again I will have to proceed by incrementing j. And this time my a of j happens to be 17. Is a of j lesser than the minimum? Yes, because you know that 17 is lesser than 29, and hence obviously the condition is satisfied, which means that I will have to update again my minimum and k. So I will update my minimum as 17 and the position k as 5. So I have scanned the entire length of the array, and finally what I have been able to find out is that the real minimum happens to be 17 and it is present at the fifth position. That is what I have been able to do. And then I'm sure you recollect that in the previous episode I had told you that once you find the real minimum, what you have to do is to swap the assumed minimum and the real minimum, which means that I will have to swap a of I and a of k. That is what is being told here, and you know that a of I happens to be 89 and a of k happens to be 17, and when I'll swap it, this is what happens. And then the remaining numbers are as they are, after which I'll have to go to the next iteration. In my next iteration, I will have to increment I, and obviously now the new a of I, which is 45, would be my assumed minimum. And you know that whatever is your assumed minimum, initially I would be placing it in min and its position, that is 1, I would be placing it in k. But you know, after all, that 45 happens to be the assumed minimum and not the real minimum. And if you have to find the real minimum, you have to scan the entire array from the next location onwards, that is from the second location onwards up to the fifth location in search of the real minimum, and that is the purpose of j after all. So this time the value of j is going to start from 2 onwards and has to proceed up to 5 in search of the real minimum. And this is the logic which helps you to find the real minimum. Anyway, let me apply this logic on the present status of the array. My a of j this time happens to be 68, and 68 is not lesser than my minimum 45, which means the condition is not satisfied. Anyway, even though the condition is not satisfied, as a programmer, it is my duty to scan the entire length of the array, and hence I will have to increment j, and this time my a of j happens to be 90, and even 90 is not lesser than my minimum 45, which means again I will increment j, and the next time my a of j happens to be 29, and you know that 29 happens to be lesser than my minimum 45, which means that the condition is satisfied. And when the condition is satisfied, obviously I will have to update both my min as well as k. So I would update my min as 29 and the position k as 4, after which I will increment j and proceed, and this time my a of j happens to be 89, and 89 is not lesser than my minimum, and hence I will have to halt my scanning here because I have reached the end of the array. So what I have been able to achieve is to identify the real minimum and its position, and you know the real minimum happens to be 29 and the position happens to be 4. So you know that the next step, what I really have to do is to swap a of I and a of k, which means I need to swap 45 and 29 like this, and the remaining numbers would remain as they are. Anyway, I will have to proceed to the next iteration. In the next iteration, obviously I am going to increment I, and my a of I, which happens to be 68, would be my new minimum, and hence I would place 68 in min and its position 2 in k. But then after all, it is my assumed minimum. I'll have to search for the real minimum, and hence I would this time start j from the next position of I, which means the value of j initially is going to be 3, and then I will have to go in search of the real minimum. You know that each time I'll have to compare a of j with min. For the time being, my a of j happens to be 90 and it's not lesser than minimum, so I will just have to proceed ahead, and this time my a of j happens to be 45, and 45 certainly is lesser than my minimum 68, which means the condition is satisfied, and hence I would be updating both my min as well as k to 45 and 4, and then I will increment j and proceed to the next location. You know the a of j happens to be 89 and 89 is not lesser than the minimum. Anyway, I will have to stop the scanning there because I have reached the end of the array, but then again I have found out the real minimum. As you can notice, the real minimum happens to be 45 at the 4th position, and as per the logic, I will have to swap a of I and a of k, which means I will have to swap 68 and 45. And the remaining elements would remain as they are, and as normal, I will have to proceed to the next iteration. In the next iteration, again I am going to increment I, and this time my new a of I, that is 90, happens to be my assumed minimum, and the position 3 happens to be the minimum's position, which I would store it in k, and then I will have to go in search of the real minimum, and hence I would initialize my j to the next position of I, which means the initial value of j this time is going to be 4, and you can notice that a of j, which is 68, happens to be lesser than the minimum, and hence the condition is satisfied, which means I will have to update my minimum to 68 and the k value to 4, and again I will have to increment j, but then this time my a of j happens to be 89 and 89 is not lesser than the minimum, and hence the condition is not satisfied. Anyway, I will also have to stop the scanning here because you can notice that I have reached the end of the array, but then again there is one more activity left, which is of swapping. So I will have to swap a of I with a of k, which means I will have to swap 90 with 68, and the remaining elements would remain as they are. In my final iteration, again the value of I would get incremented, and a of I, which is 90, is treated as the minimum, and k is going to be 4, and then j starts from the next location, which is 5, and as you can notice, a of j, that is 89, is lesser than the minimum, and hence as per the rule I am going to update both my minimum as well as k, and since I have reached the end of the array, I would stop. what I next have to do is to swap a of I with a of k, which means I have to swap 90 with 89 like this. And the remaining elements would remain as they are. And now you can notice that the elements in the array have got sorted in the ascending order using selection sort. I am sure that this episode has helped you in understanding selection sort in greater detail. Though you had already understood selection sort through our previous episode, yet this episode has given you the complete clarity that is needed for you to go ahead with coding. Also, you have understood the relevance of the variables I, j, k and min in as far as giving me my numbers in the sorted order. So, you have all the ingredients with you now. All that you have to now do is to summarize all of this and convert it to a programming code. And how do we do it? If really that is the question that is bothering you, watch my next episode.